Hi. So the next rule we're going to deal with is the quotient. So look, now we're imagining that now we're having the case where y equals to some z of x is a function it can be thought of as a quotient of two different functions. So as we divide one function by another. Now, first thing we need to do is to prove what is the derivative of this quotient. So we are looking, of course, for z prime of n because we are calculating derivative at n. And by definition, this is limit with x approaching n out of z of x minus z of n over x minus n. Now, what we can do is to utilize the information we've got over here and substitute for z. So we've got that this is limit with x approaching n out of f of x divided by g of x minus f of n divided by g of n, and this whole thing divided by x minus n. Okay, again, we've ended up with expressions that are not very pleasant, so we need to do something to make them more simple. And look, I'm going to do following thing. I'm going to take out of this expression 1 over g of x multiplied by g of n. Okay, look, because now I have taken g of x times times g of n out of both expressions, right? I need to make proper adjustment to both of those. And look, so what am I going to get over, instead of this? Look, if I'm going to take, what I need to have is that f of x over g of x must be equal to 1 over g of x times g of n times something, right? What is this something? Well, look, definitely those two over here are canceling each other out, right? So what I need over here for those two sides to be over, it to be equal, on the other hand side, is f of x, right? Now, but this is not enough, because look, what I have now over here is f of x over g of n over n, those two cancel each other out. So, if I would leave it like this, I would have f of x is equal to f of x times g of n, which of course is not true. So what is the thing that I'm missing? Well, I could add here another g of n, right? So look, now we've got that f of x is equal, f of x over g of x is equal to 1 over g of x times g of n times f of x times g of n. Those two cancel each other out, and we've got f of x over g of x is equal to f of x over g of x. So, after this step, what I'm simply going to get as a result is f of x times g of n. And now, look, the same thing, reasoning, I could have over here. So what would I get? F of n times g of x. Okay, so that is the first step we need to take in order to find this derivative. But still, this is not enough. Again, I need to use the same trick I've used before when we were dealing with product term. So what am I going to do is that I'm going to add 0 to the numerator in this equation, in this fraction. Okay, so I got that. This is limit with x approaching out of 1 over g of x times g of n. And now we will have very long fraction bar. And I will have here that this is f of x times g of n. And now, look, what I'm going to do is subtract f of n times g of n. And I'm going to add f of n times g of n. Those two sum up to 0, which means, again, we have not changed this expression at all because we just added 0 over here. And we got that this is minus f of n times g of x. Actually, we didn't need even such a long bar. Okay, all divided by x minus n. Okay, so now let's try the same trick also as we did before, and let's try to split this into two separate fractions. Okay, so we're going to get that this is equal to limit with x approaching n out of 1 over g of x times g of n times f of x g of n minus f of n times g of n and divided by x minus n. And now we have plus f of n times g of n minus f of n times g of x. And divided by x minus n. Okay, now look. We are almost ready to get where we want, but I'm going to do here one last simple trick. Look, I'm going to take minus out of this entire expression. Okay, so let me rewrite the rest the way it was. So we've got this as limit with x approaching n out of 1 over g of x times g of n times f of x times g of n minus f of n times g of n divided by x minus n. And now look, if I'm going to take minus out of this expression, this plus is going to turn into a minus. And what is going to happen inside? Look, I'm going to have minus up front here and minus up front here. So this minus is going to turn into a plus. So I can put this expression up front and this expression second with the minus. So I'm going to have f of n times a g of x minus f of n times g of n divided by x minus n. Okay, and now let's take the common part that we get out of each fraction. So look, I'm getting that from here that this is the limit with x approaching n. And here I have 1 over gx times gn. And out of this, common part is gn. And what I have left is f of x minus f of n over x minus n. And, of course, here we should have parentheses, now minus. Here the common part is f of n. And then we have left g of x minus g of n over x minus n. Okay. And finally, we can start using the limits theorem and limits theorems we've discussed previously. What did we learn? We know that the limit of a product is a product of two limits. We know that limit of a difference is difference of two limits. So I can rewrite this entire thing into 5 separate limits. Okay. So what am I getting? What am I getting over here? Look, I'm gonna have that this is limit with x approaching n out of 1 over g x times g n. This whole thing times limit with x approaching n out of g of n times limit with x approaching n out of f of x minus f of n over x minus n minus limit with x approaching n out of f of n times limit with x approaching n out of g of x minus g of n over x minus n. Well, fine. Okay. Now we are ready to calculate those limits. Look, this limit, what is happening over here? As x approaches n, g of x, this should be n, I'm sorry. No, n over here, yep. And g of x turns into g of n. So look, the first thing over here would be expression 1 over g prime n. Okay, here we already have g of n, so as x approaches n, we still have g of n. What do we have over here? This, by definition, is the limit of f function with x approaching n. So this is f prime of n. Then minus, here we just have f of n. And over here, we've got, by definition, derivative of g function at n. So this is g prime of n. And at this very moment, we have proved the quotient rule. So what does the quotient rule say? Look, if you want to find a derivative of a quotient of two functions, it's given by derivative of the first function times the second function minus first function times the derivative of the second function divided by, sorry, it should be square here. Of course, remember, here should be square, times g squared x, divided by g squared x. Okay, so with this, we have actually proven what is the quotient rule. And you see the quotient rule over here. Now let's do a couple of examples to work out how this rule works in practice. Because I know that this derivation was very lengthy and unpleasant. So now let's see how easy it is to use this rule in practice. Okay, so let's just say that y is equal to 4x to the power of 3 minus 2x squared plus 3 divided by 2x to the power of 5 minus 3x to the power of 4 plus 7x. Okay, and look, just as in case of the product rule, we can imagine that this is our function f of x, and this is our function g of x. So, when we want to calculate derivative of this function, what do we need to do? Let's just follow the formula. Look, first thing is that we need to take whatever is in the bottom, so in the denominator, and raise it to the power of 2. So we just take the denominator, we leave it exactly the way it is, and we raise it to the power of 2. Then we need to start the work upstairs. First, I'm calculating the derivative of the first function, the function at the top. So I got that this is 12x squared minus 4x. Right? And multiplied by the second function, 2x to the power of 5 minus 4x to the power of 4 plus 7x. Then minus, I rewrite the same function, so 4x to the power of 3 minus 2x squared plus 3. And then I calculate the derivative of the function at the very bottom, so in the denominator. So I got that this is 10x to the power of 4 minus 16x to the power of 3 plus 7. And it's done. Okay, let me just show you one more example. The maybe easier, shorter one, not to confuse anybody, and we can be done with this rule. So now let's just say that y is 3x squared minus 2x over 7x to the power of 3 plus 4. Okay, so again, we are imagining that this is our f of x, and this is our g of x. And now, how do we apply the rule? So, dy dx. Okay. I calculate the derivative of the first function, which is 6x minus 2. Then, I rewrite the second function, 7x to the power of 3 plus 4. Then, minus, I rewrite the first function, and I calculate the derivative of a second function, which is 21x squared. Then I'm taking the g function and I'm taking it to the power of 2. Okay, this is how we use the quotient rule. Okay. In the next video, we're going to learn how to use the chain rule. Thank you for your attention.